All right, everyone. Well, welcome. Thank you for joining us today for the Professional Development Workshop, Designing Data Visualizations for Greater Impact. The Duluth Chamber is grateful to provide this offering free of charge to our members because of the generosity of our sponsor, the College of St. Scholastica Stender School of Leadership, Business, and Professional Studies. Before I introduce you to our speaker today, I'd like to invite Rick Revor, Dean of Strategic Development at the College of St. Scholastica, to say a few words on behalf of their sponsorship.
Thanks, Aubrey. I'd like to thank the Chamber team for offering this series, and the Stender School is honored to sponsor it. Quick update on the college. Tomorrow, we're breaking ground on our new Student Center project that we're building on campus. It'll be attached to the Mitchell Auditorium. It's a $17 million project, and we're really excited to get that started. We're also enrolling students for the fall start of our Master's in Applied Data Analytics program, our MBA in Leadership and Change, and also our new Master's in Healthcare Administration. If you have any questions on these programs, please let me or Brandon know. Finally, thanks to Dr. Brandon Olson for presenting today. Brandon founded our Master's in Applied Data Analytics program at the college. Aubrey?
Awesome. Well, sounds like St. Scholastica has a lot of really exciting things. So thank you for sharing that news with us. So at this time, I have the pleasure of introducing you to our speaker for today, Dr. Brandon Olson. Brandon Olson is a professor of data analytics, IT, and project management, and director of the Master of Science in Applied Data Analytics and Master of Science in Project Management at St. Scholastica. Not only does he teach courses at the college, but Dr. Olson also serves as manager of the local outreach program for the Mini Analytics Duluth chapter. So Brandon, thank you so much for joining us today to share how we can grow our business by creating meaningful visualizations. I will now pass things over to you.
All right, thank you, Aubrey, and welcome everybody. So today we're going to talk about visualizations and creating ones that have greater impact. So, as part of my role as director of the Applied Data Analytics program at the college here, I work with our graduate students in their capstone projects, and I see varying degrees of success with the visualizations that they're creating. So I thought it'd be helpful to kind of go through some the thought process that goes into creating visualizations that serve a purpose. And so that's what we're going to look at today, because there's as you understand what goes into creating effective visualizations, you're going to see about 90% of the visualizations out there are lacking some element or another. So I think these are going to be some important things to keep in mind as you create your own here, and also understanding why you're creating them. So our learning outcomes for today. First, we want to determine the goals for the data visualizations that we create. We want to be able to apply criteria for selecting the correct plot, the correct way to represent our data. We want to be able to incorporate important design elements into the visualizations that we create. And we also want to evaluate the effective and ineffective visualizations. Now, as I go throughout the presentation, feel free to use the chat if you have questions. And at the end, we're going to be looking at some visualizations, and I'll want you to use the chat window to put in your comments on what you think about the visualizations. Also note about the visualizations, I'm using examples, and almost everyone has a flaw in them in one form or another, but they're kind of serving their purpose. So keep that in mind. All right, topics. So what we're going to talk about is beginning with the framing questions that we consider as we design a visualization. The plot selection criteria, using different plots based off of what we're trying to represent. The design considerations that we bring to mind as we're coming up with our visualization design. Some structural considerations to make sure that we are honest in our display of the data. And then being able to evaluate visualizations. We'll have some practice with a few visualizations at the end here. All right, so let's begin with the framing questions. So these are the questions that we need to ask ourselves before we begin developing visualizations. So first is, who is my audience? So it's really important to understand who is going to be looking at this data. What level in the organization are they going to be looking at high level or maybe more detailed information that they're looking for. So the audience and the context of that audience is going to be important. And part of that is what questions do they have? So we are developing these visualizations in response to some type of question. We're analyzing the data to answer this question. So we have to make sure we understand the question before we go ahead and start putting data together, because if we put these great, beautiful plots together, but it's really not answering the questions that need to be answered, they're pretty ineffective. And then as the second half of that is we have to understand the answers that we're providing. And our visualizations should be designed around providing a very clear answer to the questions that we are being asked to answer. Also, as part of that is what we consider what we're trying to say. What story are we telling? Now, it's important to balance storytelling and being objective. Our data analysis is objective, but the data tells us something, and we need to make sure we have that as part of our story that we're telling. We're trying to show the results, these objective results, and tell that in the story, and our visualizations help us do that. Also consider what other questions will the visualization inspire, or what other conversations may result in this visualization. So anytime we do some type of analysis, we're going to get answers, but we're also going to be creating additional questions. So if possible, we try to provide supplemental visualizations to start answering those questions that we have or that we anticipate arising as a result of our initial study. And then also make sure that all of our visualizations should lead towards some type of actionable response. When we do data analysis, there's some type of action-oriented result that we should be anticipating. And so we should be working towards that, looking at some way that we can provide some direction for an actionable response to the questions. So these are the elements, or these are the questions that you should be asking even before you think about what type of visualization you want to do. You need to consider these factors. Now, another thing to consider is the data. So what data do we have available to us to conduct analysis on? Is it an actual measurement of what we're trying to answer, or is it kind of representation of the measurements that we're going to be answering? What is the scope? So do we have all the different attributes around the problem domain, or are we limited in the attributes that we have access to? Also the scale. How large of data set do we have that provides a more, maybe a better view of the data? And then also the quality of the data. Are there formatting issues, missing data, inconsistent measures? All of these represent different limitations of our study. So we can still work with imperfect data. We just have to recognize that it's going to have some limitation. It's going to result in some limitations in the results of the study or of our visualization. All right, so now once we figure out what we're trying to do and we've identified the data that we're going to use, now let's think about how we're going to represent this data. So we're going to look at different forms of representation, different plots that we can use to represent our data. And it's really going to be dependent upon the data that we have. So first, we need to determine what type of data are we working with. Quantitative data, or is it qualitative data? So for qualitative data, it could be considered nominal. So these are just named categories, such as eye color, or I like baseball. We have a lot of baseball data in this presentation. So like player position, pitcher, catcher, first base, those are all nominal data elements. The other is ordinal. So that means that there's some type of order to the data, such as shoe size or batting order. So there's an implicit order to the data, to these different naming categories. And then on the quantitative side, so dealing with more numbers than words, we're looking at either continuous or discrete variables. So are they whole numbers, such as like number of kids, population size, number of home runs. So these are whole numbers that can't be subdivided. Or continuous variables, such as weight, temperature, earned run average. These are decimal values, whole numbers that can be further subdivided. Now, if it's a continuous variable, we also can break this down further into interval or ratio scales. So interval scales, these are going to be that data that don't have a true zero. So such as time, age, or baseball inning, there is no zero in each of those. That you have an age. There is certain a time. There's not a zero time in any given day. Ratio scale is going to have a true zero. And it's also, again, it's another continuous variable, but it has a true zero, such as weight, speed, earned run average. All those can have true zeros. So it's important to understand the type of data that you're working with, and that will help you better understand, partially understand what plots you're going to use, but also how to represent that data on the plot. All right, so next, how to display the data. So there's the different considerations that's going to lead to the type of plot that we should be looking at. So do we want to compare different categories? Are we looking at variables over time? Maybe distribution of a variable, perhaps geospatial data, or relationships between two variables, or a part to a whole. So what part does this element contribute to the entire? Maybe there's qualitative data. Also, we can look at kind of the antithesis of visualizations, tables. They're also useful. So let's begin by comparing categories. So when doing data visualizations, really the bar chart is your default choice. This is a great way to show both X and Y axis, and a great way to compare categories. So in this case, we see the career home runs between Barry Bonds, Hank Aaron, and Babe Ruth. And we're able to clearly see that they're very close, but there are some differences. And we have a good idea of the approximate number of home runs each of these players have had over their career. Now, we can also have a bar chart tipped over. So do a horizontal bar chart. And this is a great way to show data, especially when your x-axis variables that we see, like Barry Bonds, Hank Aaron, if those are going to be longer, that they won't really fit in your plot, all we have to do is just flip it on its side. So our x-axis is really converted to the y-axis, and y-axis is converted to the x-axis. This gives us more space to put our x-axis labels. So these horizontal bar charts are an effective way, especially when you have longer x-axis labels. And then finally, we can do grouped bar charts. So in this, we can see the home runs by month for each of the years. So for each year is a category, but we further subdivide each of these categories by month. And so we can show the number of home runs for March, April, and March, May, June, July, and August. So bar charts, they're going to be the most common, and they're very, very useful. So that if you're not sure where to start, that's a great place to start. Is let's look at a bar chart. Now, another alternative for comparing categories is the bubble chart. So this is a different way to show relative size, or relative size representing the quantity. So here we're seeing the professions of people that create programming languages, and we can see that computer scientist is the most common category. But the problem with any of these circle features for size is really it's hard to discern, is programmer, university teacher, mathematician, which is the larger, and one is larger, but it's really hard to determine which is largest. So there are some issues with bubble chart. They're different. It takes a little bit longer to interpret because we're not used to seeing bubble charts as bar charts. My preference is bar charts. They're quicker to interpret, and we can see minor differences a lot easier than we can with a bubble chart. So bubble charts are another option. Now, as I go through these different forms of visualization, I'm just hitting the kind of the most common ones. There's a lot of other ones that we're not going to include in this presentation, which some of them are useful, but keep in mind, you want to try to stick with visualizations that people are used to seeing so that they can more easily interpret the visualization. So yeah, we can get fancy and do some obscure visualizations, but they may not be as effective because it's going to be challenging for our audience to understand and interpret what we're trying to say in the visualization. So that's why we're going to stick today with just the most common forms of visualizations. Now here's a fun one, the isotype chart. So this one, what we're using is some type of icon or representative icon to form different bar charts. So here we're looking at hot dogs consumed, and so it would make sense to show little hot dogs. So this is kind of maybe a cute way to do it. It really drives home what the topic is. So that's another way to do a form of bar chart. Now with this one, this is almost one that could be done as a horizontal bar chart. Other than the hot dogs might not stream kind of work well, but because of the x-axis labels are so large, it's going to limit the number of teams that we can include in here, and we have to work with some spaces. So this is one that could be a horizontal chart also. All right, now if we're looking at data, a variable over time, so a time series, we're really looking at a line chart, and that's an effective way to look at data over time. In this case, we're looking at multiple categories of data over time. So we have a multiple line chart. So we can see the annual ticket sales by Major League Baseball, Minor League Baseball, National Basketball Association, and National Football League. And we're seeing those over time. Now, one thing that's to note on here is that we have to, part of the challenge is if we're going to have multiple categories on a line chart, we have to have some way to differentiate between them. So in this one, we have different colors representing each of the different leagues. But this shows kind of fluctuation for each of the leagues over time. And so it's the timeline, or the line chart is a great way to represent a variable over time. And so if you are looking at time series, this line chart is going to probably be default way to represent the data. All right, and kind of another way to do this is an area chart. Now, area charts are a little bit more complex to understand, but you also can represent more different additional attributes than just measuring a single value. So this is an example of a stacked area chart. So we're looking at music sales since 1973. And so what we're seeing is, if you take a kind of, you see my cursor here, this is the total music sales. And then of that total, we can see the relative size shows the amount of the music that was distributed as 8-track tape, vinyl, or cassette, or more recently, compact disc, downloads, stream, or others. So this allows us to show multiple dimensions of variables. So we're measuring the sales over time for each of these mediums, but we're also showing the total sales at the same time. So this is kind of a cross between like a pie chart and a line chart. So this allows us to add that third dimension by doing the stacked area chart. So that's a way to get a little bit more complex with your time series by introducing not just the single variable, but the collection of the variables that measure as well. And that's where the stacked area chart works well. All right, histogram. So this is showing distribution. So if we're looking at distribution of a variable, we can see how that variable is distributed in terms of like the low values, the high values, and the values in between. And this, probably you've heard the term normal distribution. Well, that comes from this type of frequency distribution. So here we're taking our variable and we're looking at the number of instances we see of each that variable value. And that shows us this distribution. And on your x-axis, you see that there's multiple numbers. So those are called bins. So rather than having each decimal, so this is batting average, so each decimal place representing one bar in our histogram, what we're doing is we're grouping them into a range of batting averages to better allow us to have fewer categories, so that's easier to read. So that's called binning, or those are bins of data rather than each individual batting average. So we're grouping the batting averages together and then showing the frequency that we see in our data for each of these ranges of batting averages. All right, so what we can also do is include error bars. So for each of these, if like in a histogram, we could have that representing like the mean of a data point or a measure, and there's going to be some variation in those means. So what we could do is we could represent that variation by error bars. And we can really include error bars in a lot of our different plots. It's just an element to consider if we want to show that there is a lot of variable or variation in our measures, that error bars are a good thing to have. It does clutter things up and it might create more questions than answers, but if you see a lot of variance, it might be an important factor to consider including just to demonstrate that there is significant variance in your results. So the results should be somewhat questioned. So error bars are a good way to show that variance. All right, and another plot that's really includes that variance is the box and whisker plot. These are fun. Probably one of the most underused plots out there. So this is when you take a look at a variable and we have different categories that we're measuring. So this we're taking a look at home run distances between Mark McGwire, Sammy Sosa, and Barry Bonds. We're taking a look at how long each of their home runs were. And so this shows us a lot of different things. So we can look for each of these players. So we have different categories, kind of like a bar chart. But what we're doing though is we're showing that there's some variability, or variance in rather than just showing the median distance for each player, we can show the range in which those home runs were hit. So the box and whisker represents the different quartiles. So the lower 25% of the distances for Mark McGwire were from about, looks like maybe 375 to 340. Those were the lower 25. The upper 25% of his home runs were about between 450 and 550 feet, which means the middle half of his home runs is represented inside this box. And the line across the box, that represents the median value, or the middle value between the lowest and the highest is represented in this box. Again, lowest is going to be, this is your minimum value, and this up here, this is your maximum value. Now, sometimes you'll see dots that go beyond that, and those are going to be outliers, and we can note those by, our bar is not going to be extended. We're just going to say after so many standard deviations, those dots fall outside of that. We want to represent them, and so you'll see them on box and whisker plots. Sometimes you'll see dots beyond the upper and lower limit. Those represent outliers in your data. But again, min, max, and this is your middle quartile, or your middle 50% with the bar representing the median. So this is a great way to show the wide range of values that you have for each of your categories. And when you're evaluating data before you begin an analysis, it's a great place to start so that you can see what your data looks like. So if you want to show distribution of data, a box and whisker plot's a great way to do that. Let's see, a Choropleth map uses geospatial data, but it's representing different densities to show different values. So like here, if we're taking a look at state population, we can see that the darker colors represent higher populations and the lighter colors represent lower populations. So we're able to take our data, apply it to a map, or a geographic area, and using color schemes to indicate the relative values. So this is not going to be intended to show actual values, but show more relative values. So the Choropleth maps work great for showing those relative values, but really showing it across the United States so that we can, or across a map region. So you can you're looking at more of trends or some generalities rather than specific data points. Now, what we could do is we could also put the actual value in each of the states so that we could mix both actual precise measures with generalizations as well. Although we have to be careful not to overwhelm our audience. So that's why it's really important to understand what question you're asking. so that we don't provide data that's not providing a clear answer to that question. Now, here's a dot density map. This shows public libraries across the United States. So each dot represents a library. And this, so as a collection, then we can see which areas of the country have the most libraries by the density of these dots. So another way to use geospatial data to represent another piece of information. So similarly, we can kind of use maybe like a heat map in this geographic area to show, again, the relative density of the baseball fans based on the geographic location. Which ones are mostly Twin fans, and as the Twins fans fade, as it moves out, maybe down now southeast, there's going to be more Cub fans. So this is a different way to represent, again, its relative fan base for each of the teams across the map. So another way to look at geospatial data.
Brandon, there's a question in the chat from Sarah.
Yes. Let's see. Aren't
reproductions of population maps?
Yes, most density maps just reproductions of population maps. The population map is a very common way to use the geospatial data, but it really depends on what you're measuring. So this one's measuring libraries. Libraries may be somewhat related to population, but it's really not a measure of population. And same for this, the baseball map, that's not necessarily representative population. So I think there are some population influences, but it really depends on what you're measuring. So if we take a look at maybe measuring the number of cows per acre, we probably would maybe see the inverse of the population. Or there's different, it's so really looking at what you're measuring, is that an attribute of population? That really would, to answer your question, Sarah, that's not necessarily true, although it's quite often you will see that it does have a relationship to population, but it really depends on what you're measuring. All right, good. All right, on to scatter plots, another popular form, and this is used to show relationships between two variables. So we have our dependent variable and our independent variable. So what we're doing is in this table, we're looking at the relationships between strikeouts and a pitcher's ERA. So to see if the ERA is related to the percent of strikeouts that the pitcher throws. In this case, we see there's maybe a slight relationship, but it's certainly not clear. So this allows us really is to evaluate a relationship between two variables. We collect our data and do a scatter plot to look at the data. And if we looked at this maybe on a table, it would be really difficult to discern. But when we put this on a map, we can clearly see there's somewhat of a trend, but it's not a clear relationship. Or what we can say that we could put a line through there to show us what the linear relationship looks like, but we would see that there's a lot of variance from there. So it would be very hard to predict an ERA for any given percent of strikeouts. So the scatter plot does show us the relationship and the relative, I guess, the variance of that relationship. So here we have perhaps have somewhat of a relationship, but there's so much variance that you can't say that one predicts the other. And that's what we're looking at, is to see if one predicts the other. And we're saying, does the x-axis predict the y-axis variable? So scatter plots are great for if you want to show the relationship between two variables. Now, another way to do scatter plots is not just on a y-axis, but you can use this on different form of maps or different form of representations. So here we're taking a look at hits, where they're the type of hits and where they're being hit on a baseball diamond. So this is a way to represent the relationship between the type of hit and where on the field that hit was made. So a different way to look at relationships. It doesn't have to be all on y-axis, but we can use other representations depending on what we're trying to measure here. All right, the bubble plot. So as I mentioned with the previous bubble plot, I'm not a big fan. It takes a little bit more to interpret, and showing differences between similar objects is challenging. but they're interesting to look at, and it really depends on what you're trying to show. So like this shows excuse me, let me move this. Right, there we go. So we can take a look at technology markets, looking at the x-axis is growth and the y-axis is salary, so that we can take a look at high cost versus high growth, and we can categorize them. And then the relative size of each of these markets is represented by the size of the bubble. So we can place our bubbles across a y and x-axis to show this relationship, but the size of the dot, so to speak, represents provides an additional variable that we can include in our measure. So while the scatter plots focus distinctly on the relationship between two variables, this bubble plot allows us to increase the size based off of a third variable. So it's a kind of a way to provide an additional perspective on a relationship between two variables. All right, pie charts. And we see a lot of pie charts out there. I think pie charts are helpful if we're taking a look at more focusing on the relative contributions to the whole, where the contributions to the whole is the important dimension that we're trying to communicate. But if we're trying to compare, pie charts are terrible because the relative size of any one of those slices is difficult to determine. So there are use for them, but if you are looking at a pie chart, ask yourself, wouldn't a bar chart be a better way to do this? But bar charts aren't necessarily good at demonstrating parts of the whole if you're emphasizing the whole. So that's really kind of that should be your differentiator when you're going to choose a pie chart versus a bar chart. So pie charts are effective to show the contributions to the whole, and we can see that in this example. But we can see like eating and drinking, grooming, traveling, which is more, and if that data, if the actual measure wasn't there, it'd be difficult to determine which is more. Now, another way to do a pie chart is a tree map. So this allows us to have subcategories. And so rather than a circle, we're representing this in either a square or a rectangle. In this case, it's a rectangle. So we can show not only their regions of the world, and then but also the different countries, and each of the boxes or each of the size of your sub-objects represents the relative size of the countries. So this allows us to kind of create a pie chart type of representation, but being able to subdivide that even further. So this tree map is a great way. If you need to have a more complex pie chart, we would look at a tree map to do that. And this allows us some more flexibility, but similar to the pie chart, if you have sizes that are very similar in shape, it's hard to determine which is larger. Vietnam, Philippines, which is larger, the numbers tell us, but if we were just relying on size, it would be really difficult to make that determination. All right, now if we're taking a look at qualitative data, word clouds are a common way to do this. The relative size is, again, what we're focusing on of the kind of, in this case, the number of instances for each of these words in a body of text. So, word clouds, we're used to seeing this. This is maybe more of a relatively new format, but it's popular enough to consider if you are taking a look at qualitative forms that you want to represent your data in. And then finally, tables. Tables, there's still value in the tables. It provides us to show a lot of different variables for any given category, in this case, every given player. So it shows a lot of information at the same time. But what you can do is also think about combining tables with plots. So if we were going to have this table, but we wanted to show maybe their war results, we could have that as a different visualization to supplement those, so we can better see the differences between each of the players. But this shows a great summary. But if we wanted to be able to communicate something specific, visualizations help us make that, be able to communicate that message. So tables they're helpful, but in of themselves, it's not the best way to communicate data, but it provides maybe the details that we want to see after seeing a visualization. So they're complementary to visualizations, but in of themselves, they're not as effective. All right, so after taking a look at all those different plots, and there were quite a few plots, but you can see that there's a lot of differences, and it really is going to depend on what data you're using and what you're trying to show. Are you trying to show relationships? Are you trying to show the variable over time? All those, depending on what you're trying to do, you're going to use a different plot for that. So now as you figure out what plot you want to do, we have to consider there's some design considerations that we have to factor in as we design that plot. So the first kind of rule of thumb is ACEs. So we want to make sure that our visualization is accurate, that it clearly represents what we want it to represent. It's empowering, meaning that it's action oriented. We're showing people what they can do, and that it's succinct, that it's very, very simple or very easy to extract information from. And it's sending a very succinct message. So for example, so I guess going through a couple of guidelines here is first, show the data. Looking at Mike Trout's scatter of his hits, this is difficult. There's a lot of data points on there, and we're having not only the placement on not only the number, but the placement on the field, as well as if it was double, home run, single, triple. There's a lot of data on here. So what we need to do is simplify this and determine what's really important for us to show. So rather than showing this kind of mess, what we're going to do is we're going to simplify that and say we're going to focus just on home runs. And now we can see where those home runs were hit without all those other different types of hits getting in the way. So focusing on what data we need to show, that's an important element. So one of our design guidelines is figuring out what data is important and focusing on that data. Don't show all the data, but emphasize, and if you do need to show it, make sure that you emphasize the areas that you want to draw attention to. Similarly, reducing clutter. So in the early days of Excel, a lot of people were doing these three-dimensional plots just because we could. But not only are they ugly, but they really add a lot of design elements that get in the way of understanding. So the simpler bar chart at the bottom has the same data, but it's much easier to interpret. That we're not trying to flatten out a three-dimensional display to interpret the data. It does that for us, and we can just directly look at that and come up with our information that we need to discern from that plot. So don't include design elements that are not emphasizing what you want to answer, what you want to show. Three-dimensional bar charts, really, there's no need for that. So simplify it. Don't make it fancy, make it informative. It's important, it's really effective to integrate graphics and text. So this is a line plot, but what you can do then is you can incorporate text in there to highlight some of the peaks and valleys to not only show the variance over time, but what that kind of your analysis of that variance of what happened at each of these peaks or valleys. So, and this not just on a line chart, but we can do that on any other chart, but if you take a look at one of your plots, if you have questions about, well, why is that? That's a good time for you to add some text in there to make that explanation. And that helps the audience understand that. Now here, this might be too much text. It really gets a little busy. I think it depends on what you're trying to answer, and keep that in mind with the text that you're going to add. Text is great as a supplement, but make sure it's focused on the question that you're trying to answer. Now, here in a line chart, we have multiple variables over time, and off to the left, this is great. But with this legend, we have to really look back and forth to see which of these bars represent. Where if we just remove the legend and then label each of these each of these lines at the end of the plot, it's much easier. We don't have to move back and forth. We can keep our eyes on the plot and follow that through. Again, it's important to use different colors, and maybe this could have been contrasted a little bit more, but we can follow along which these lines represented much easier than going back and forth. Now, another thing that we see here is we have an action-oriented title. So this is not necessarily, I guess, partially action-oriented, but rather than just using the subtitle percent of women majors by field, well, what are we trying to convey? We're really focusing on computer science. So we're kind of shouting out the question, what happened to women in computer science? So this is much more of an action-oriented, or really causes your audience to focus on what you're trying to get them to focus on. So use the visualization titles to help emphasize what you want to emphasize. So don't just use a descriptor. Descriptor's fine, maybe you put that in your subtitle, but use the title as a way to really shout out what you want them to see. Another guideline, avoids the spaghetti chart. So here, this shows this pie chart, but there's just way too much data on here. What are we supposed to get out of this? The thing is, it takes a lot of time to take a look at this, and your audience may just move on to something else. They might not want to spend all the time trying to extract all the information from here. So be succinct in kind of identifying what you want this display to, with this visualization, to tell the audience, and keep it simple. This is a way too complex of a plot. Now, what you can do is you can take this visualization, or a visualization, if it's getting too complex, break it down. Here's how you can do this: is you can break this down into different regions or different subplots. So what we're doing is we have a lot of data here, but we've simplified it by having different separate plots, again, for each of these categories. So this is a way to avoid the spaghetti chart, is by having different regions, or subplots. So rather than putting everything together in a single plot, break it out into subplots so that it's easier to extract that knowledge that you're trying to share. Other thing is, start with gray. Don't overwhelm the audience with color, that you can use color to emphasize certain things. So here we're focused on bananas, that bananas is what we eat. So what we can do is leave everything gray, so the data is still there, but we're causing the audience to focus on where we want them to focus on. So color is a great way for attention. So start with no color so that you can use color to emphasize. And then final guideline is iterate. You're going to build your plot, you're going to test it. Maybe the testing is with yourself or with others, to see how easy is it to interpret. Am I getting what I need out of that plot? Then redesign it, build it again, test it. This iterative process until you get to an effective visualization is what you're after. Next, structural considerations. And I mentioned some of these. The title. It's important that you have a title. Plot in of itself is not sufficient. You need to tell the audience what they're looking at. So a title is important, and that action-oriented title is really what we're looking for. Making sure that we have access and labels. So, what is this? Is this dollars? Is this quantity? If it's quantity, is it what period of time is it? So this really doesn't answer a lot. And is this just a specific apple, or is this all apples? So even down here, the x-axis, while it seems it's somewhat descriptive, it may be open for interpretation. So what we want to do is make sure that our visualizations are not open for interpretation, that we provide the labels to explain to the users what we're seeing. The Y range. So here is you see this frequently, a way to represent the data, but it's really misleading. So this here plot, we're taking a look at a bar chart of categories A, B, C, D, and E. We're seeing that there's a dramatic difference between A and E. But if we take a look at that, we're starting at 900. So if we're taking a look at this more realistically, there's slight differences between the two. So because we're using a partial y-axis, it really misrepresents the differences between the categories. So it's better to have your y-axis start at 0. Now, it depends on what you're measuring. If it is a value that does not change, that there is only going to be slight variance, and you need to show some variance, there's a better way to do that, and that's this 0 break, so that we're pointing out to the audience that this doesn't go all the way to 0, that this is just showing at the difference is at the upper half of this range. And that's a little bit more honest. I prefer this one on the right. If we want to maybe better show the differences, then we can use this middle one, but then make sure you tell the audience that it's not a zeroed y-axis. Another way, x-axis range. So here we're taking a look at the length of baseball innings or baseball games, and we can see that there's a dramatic increase from 2005 to 2015. But the thing is, we're only showing a short period of time. If we take a look at this plot, we can see that that was just because there was a valley beforehand. So that dramatic increase is not dramatic, but rather it's an increase over time. So we can misrepresent the data with the zooming in on the x-axis as well. So we have to be careful, and also as audience, ask these questions too. Why are we selecting that x-axis? Is that important, or should we be seeing more x-axis or more y-axis in the results? So these are different ways that your data could be misleading. And as I mentioned before, orientation, these bar charts don't all have to be vertical. Horizontal bar charts show the same thing, and they're still easier to interpret, but it gives you more space to include your x-axis labels. All right, so we've got a couple minutes here. Let's go ahead and use your chat here, and I'm going to show you. I've got a small number of visualizations that have several problems, and I'd like to have you kind of look at this and evaluate for yourself what problems you see with each of these visualizations. So, other than this being a pie chart, what are some problems here? So go ahead and, yeah, there we go. No labels. You have no clue what it's showing, right? We don't know what that is, right? So there's titles that are missing. So right, we have no idea what the measurements are, and we have a legend here to show each of these colors. And there's a lot of different colors, so it's hard to differentiate between there. Map those back over there. We have some similarity in colors. I see that Sarah mentioned that. That's great because it's going to be hard to then map this to over here. And I think there's so many different categories. It's hard to get different enough colors. A bar chart's a little bit better, but we still have issues with, well, what do each of these categories mean? And the x-axis is not labeled, or the y-axis is not labeled as well. So this is percent of what? I guess percent of the whole perhaps, but the title is missing as well. So there's a lot of issues with that. All right, what's wrong with this? So this is we saw this earlier. So what do we have an issue with here? Yeah, again, we don't have title. What are we measuring? There's no descriptions or no x-axis and y-axis labels. We can make some guesses, but we're not sure. But certainly the y-axis is missing. We could say that these are standard deviations, perhaps, but we don't know for sure. And no descriptors. And again, no title. So what are we measuring? And why are we having that variance? Why is that important? And when we see those error bars, there should be some reason why we're showing that. And that's really hard to tell. So this plot is not enough. This really shows that we need to have our labels on there to help the reader the audience interpret that plot. And one more. So here's another one that I showed earlier. This is a grouped bar chart. So here we have y-axis and x-axis labels. So what could we do better here? This is a kind of a tricky one. Any guesses? Oh, total home runs could start further up than 0. Correct. Yeah. So we could shorten the length of our y-axis. I don't think it's causing problems, but it really reduces the differentiation between the different groups. Correct. We could put March and April. I think we'd see March is so small. Maybe that's why they combined it. But yes, it is combining them where the other ones are not. Purple shows 2 months. Right. Yep. March is in April. Better is a line graph. Now, Sherry, that's a good point. This could be done by a line graph. But now, what is it? Now, what is it about the line graph that we did to be able to better differentiate to eliminate the need for our legend? What did we do to eliminate the need for our legend? So right now we're having to look at the legend back and forth, back and forth. And what we could do is take those labels. Yes, who said that? Whittington. Move those labels from up the legend, and we can just embed them vertically here. And it could be just this first set, or we could put them in each of the years, but moving them actually into the data. And there's space to do that. So we could put the March, April, May, June, July in each of these, maybe in white, so that we don't have to go back and forth between the legend and the actual bar. So this one's a little bit better. I think having more of a call to action title could also help, but this one's not too bad. But we can see here, we would just view this as a normal visualization. But if we inspect it, knowing what we know now, we can see some areas of improvement for the visualization. All right. And then here, what do we have wrong with this one, or what could be improved? So I guess just for a matter of time, we could have a call to action in the title. This is implied 3 hours and 45 minutes, but we don't really know that for sure. It requires us to really think about that. We could put the label there. So put a label on our x-axis, maybe on the y-axis, maybe on the x-axis. I would say that we probably want to explain this was, I bet this was a strike season, and that's why there's missing data point in between, but we should explain that as well. So when we evaluate our plots, we want to make note of, well, if I were looking at that as my audience, what questions would I have? And we should then address that by providing some additional supplements to be able to answer those questions. Huge range. Right, there's also a huge range. Well, why is it important that we went all the way back to 1970? Is it? Maybe it is. But we'd have to explain why 1970, why not 1960, why not 1980? So there has to be some rationale, and maybe that would be explained in our title as well. All right, so when doing visualizations, we need to understand our audience. We have to make sure that we're answering their questions. That's what the visualization is all about, is providing an answer to their questions. Anticipate what questions are going to rise from that, just like that last one. Why was that gap? Let's explain that in our visualization. So make sure that we're also answering these anticipated questions that we're going to get. Make sure that we're providing some type of actionable answers. Perhaps we can do that in the title of the visualization. Make sure we're selecting the right data and the best plot. Consider these design practices to make the visualization easy to understand. That's the key. We want this information. We're sharing knowledge with our users. And we do that best by making sure that this visualization is properly communicating what we want it to do. So we're going to structure the communication to focus on that knowledge that we're trying to disseminate. And also we're making sure that our structure provides an honest answer. We don't use our axis or different formatting techniques to send a different message than what the actual results reveal. So we can be tricky with our visualizations, but make sure that we're using our power for good here. All right, so both the information, in addition to my experience with working with my students, use these two articles, and actually this book is really good. I just bought that recently. And it provides a great, it's a great resource for doing data visualizations. It's not too expensive either. So consider that. So with that, do we have any final questions? And if you hold on to after questions, I can give you access to download the presentation too.
Any questions for Dr. Olson? If not, I have one.
Okay.
I'm wondering, so I was looking at our attendee list, and there are lots of nonprofit professionals I'm noticing, and a few small business entrepreneurs. So I'm wondering, Dr. Olson, thinking about kind of creating data visualizations kind of in those worlds, like with nonprofits, I think of an impact report maybe. Have you seen anything really impressive that maybe a small business or a nonprofit has done with kind of presenting data that kind of stuck out to you, or any advice that you would specifically have for these leaders that are on the call? Because I think that would be really interesting to kind of situate it with who's tuning in today, because I've seen some really beautiful impact reports. Like Target had a really cool like corporate sustainability report that I remember had a lot of graphs. So I'm wondering if you've seen anything in your travels that you could share about with the group, kind of based on their experience.
You know, I don't think it's so much of the subject matter, but more of what are you trying, what's important to your audience. So if it's nonprofit, is it going to be important to show the effectiveness of your organization? And if that's the case, do you have specific KPIs that you use to measure that effectiveness? And which of those do you want to be able to communicate? So it's really understanding who the audience is and what story you're trying to tell. So I think those, using those considerations to design your visualizations is very, very helpful. Now, regarding the tool, I saw somebody asking about the tool. So a lot of these were just screen captures or from different images. But if you want to get into this and you have data to work with, I recommend, well, I mean, you can do this in Excel. I think that's a good entry point into it. But there's also the product called Tableau. That's an industry standard for developing data visualizations. And Tableau, it's expensive, but there's what's called Tableau Public. And that's a web-based version of Tableau that's free. You can use that, and it's pretty much all of the functionality. It's just that it's the data stored out on their server, and it's accessible to anybody that knows your URL. So it's not necessarily, it's somewhat protected because they'd have to know where to find it, but it's a good way to practice and to be able to use Tableau software for free using just your browser. So Tableau Public, I recommend that as a great entry point into learning how to do visualizations.
Looks like there's another question about adding a narrative to your graphs.
Yeah, so a lot of these visualization tools have a text tool as well, and that's simply just placing text at the appropriate places on your graph. In addition to that, these visualization tools have specific x-axis, y-axis titles. So the main elements of the visualization, those main text elements, those are a part of the plots. And then you're free to add additional text to that. Now you can also create visualizations that are more interactive, and you can have, based on where your mouse is, some text may appear. And so there's kind of that other additional form to keep it clean, but then provide additional information by your mouse over events. So that's another way to do that.
Wonderful.
All right, so
any other questions? And you have a QR code for them to scan for the slides, correct, Dr. Olson?
Yep, so if you want to download a PDF of the slides, you can just use that QR code to scan that down. And if you want to connect with me, I'm on LinkedIn and Twitter. So I thank you all for coming to the presentation. I hope that you learned something. I hope this gets you excited about doing visualizations and gives you some things to think about. It's not just a matter of sitting down and whipping something out. A lot of thought needs to be put into this to make them effective.
Wonderful. Well, thank you everyone for joining us for today's professional development workshop. This concludes the session. Feel free to reach out to Dr. Olson afterwards if you think of any last minute questions, and we wish you a wonderful afternoon. I'll leave this up for a little while in case people need the QR code.
Okay, great.
Thanks, Dr. Olson.
Thank you.